All right, we're going to be taking a look at our next lesson in Unit 5 from Chapter 3. And in this lesson, we're going to be taking a look at a particular type of word problem that pops up once we start to discover the power of sine law for solving triangles. Then we can start to handle a very interesting type of word problem, which involves bearings. So we want to make sure that you understand what bearings are, what they mean, how we write them, and then some strategies for solving these problems. And all this is based, of course, on this new relationship that we discovered, which is called the law of sines. And remember that what it means is any side divided by the sine of its opposite angle gives me a number that is consistent no matter what my angle is or side happens to be in a triangle. And remember as well, if it's convenient, that you can write this with the sine of A on top and the sine of B on top and the sine of C on top. As long as all of them have one thing on the top and the same thing on the bottom, then you're in good shape. So remember as well that the beauty of the sine law is that it gives us some strategies for solving triangles when they do not have a right angle. So if they're just an ordinary acute triangle, we can jump into using the law of sines. Now, we're going to be taking a look at the law of sines, in particular in a style of question called navigational problems. Now, this involves using something called a bearing, and a bearing is where we're talking about the direction that an object has moved or gone as it relates to north. This is all based on what was done historically speaking for any type of navigation, whether on the ocean, in the air, or in the woods or wilderness. And of course, it's very historic. If you were to look at something like this, you're going to see lots of trigonometry. You're going to see lots of things that are very familiar and interesting to what we're working on right now. And basically, to understand bearings, there are two styles of writing it. One is called the compass bearing. And the compass bearing means that you refer, first of all, to whether you're going up in the northern direction or if you're going south. And then you describe where you're going from north towards the east or towards the west. So, for instance, in this particular angle that we're looking at for A, we are going north 30 degrees east. As I move around, then this one would be going south 70 degrees east. This one is going south 80 degrees west. And this one is going north 60 degrees west. And so those are what we call the compass bearings. You can also do this similar thing, except we call it with true bearings. And these are also called sometimes three-figure bearings. And what that literally means is that you consider north to be 0 degrees and then move counterclockwise around the coordinate plane. And so that you are naming where the direction is. So for this first one that you see at P, they're saying that it's 0, 65 degrees. So they've gone from north 65 degrees. Whereas the one in blue has gone all the way around 300 degrees. And so this one would be indicated by 300 degrees. You're going to see both, and I would encourage you to play back and forth with them so that you can get used to them. So, in terms of getting some strategies for working on these problems, first of all, make sure that you make your diagram a good size. Use a ruler, take some time to draw it. The better your diagram is, the easier it's going to be for you to understand where to find the information you need. Always add compass lines, usually in another color with dotted lines, just to kind of make so that they don't get confusing with the actual lines of what you're drawing, but always include those compass lines. And then look for angles that you can identify. And think about parallel lines and perpendicular lines and supplementary angles and so on. So here's a question that we worked on as well in class. And so take a few minutes to read it. You'll notice that they've actually drawn you a diagram already. And basically what they're saying is that this boat needs to deliver supplies to Lighthouse B and Lighthouse A. Shows you some distances between things. And they also tell you the directions, compass bearings. So it says the compass indicates that the lighthouse to the left is located at north 30 degrees west, whereas the lighthouse on the right is north 50 degrees east. So the question that they're asking us to do is to determine the compass direction he must follow when he leaves Lighthouse B, right here, for Lighthouse A. We want to know, how would we tell someone where he's actually going? So I've drawn the same question, but I've just made sure that I have a few more compass lines in here, putting them everywhere. Here's 30, here's 50. And what I want to know is if I'm here at B, what am I doing? I can tell I'm going to be moving northwest, but I need to know the size of this angle. So I can tell if I look at this as a triangle right in here. So I know this is 90 degrees because those perpendicular lines hit at 90 degrees. I know that this is 50 because they told me. So that means my angle in the corner is 40. You could have also thought of it as if this one's 50, this one's 40, and then you would have alternate interior angles. Lots of different ways you can find it. But what I really need to know is what is this little tiny angle right in here? So it would be helpful if I could find angle B. So look at my triangle. I know the side 12 is opposite 80 degrees. I know the side 9 is opposite the one I'm looking for. So I'm going to set it up. And when I do, using the law of sines, I find that angle B is 47.6. So if this whole thing is 47.6, that means this little tiny guy is 7.6. So when I go to name the direction, I'm going to say that it's north, 90 degrees minus 7.6 to the west. And that's where I get my answer of 82.4. Okay, that should give you enough to at least get started. Make sure that you're working on the following questions and bring your frustrations to class so that we can try and settle things for you. Good luck, everyone.